All right, so we're going to start with number 3 here. This is one of the reasons I really like to do the that form that you guys fill out to say which problems to do. Because I probably wouldn't have guessed that this was one of the problems that most people needed. Because we got this battery doing this much work as this much charge passes through it, and we're asked to find the voltage of the battery in volts. So let's see, this is number 3, and so my Y would be that something like voltage describes the amount of energy each charge has. And so start with the big equation that voltage is energy per charge. And I'm looking for V. They tell me the energy, 59 joules. They tell me the charge, 6.6 coulombs. My answer will be in volts because it's joules per coulomb. Yay! And there was much rejoicing. All right, and number 2 kind of fits within the theme of number 2 and number 3. This one is, do you know the definition of current? Because it's telling us this 21 picoamps is the smallest current that this meter can read, and how many electrons per second flow through the wire. So this is number 2. Current is the rate charge flows past a point. So current being a rate is delta T, and so it's delta Q, the amount of charge, the rate the charge is passing. All right? And we know, I think mine was 21 picoamps, if I remember correctly, yeah. And they want to know how many electrons per second pass through the wire. So, I can leave this in terms, they say 1 second, the amount of charge. And I know that the amount of charge is, from previously, the charge on a single electron and times the number of electrons. Right? So let's see, 21 picoamps equals the charge on an electron, or 1 quanta, times the number of electrons. And this is over 1 second. They actually left it in terms of delta T. We could do that. Let's do that. We'll leave this in terms of delta T. Because they asked, if you look at what they asked for the number of electrons per time. See? They use capital N, lowercase e. They're a little fancier than me, delta time. So now just rearrange that. You have the value of a single electron, 1.602 times 10 to the minus 19 coulombs. So it's just a rearrangement now, right? Yes, no, maybe, algebra. Oh, it didn't come out on your screen? And so you're going to end up with, in my notation, number of electrons per time will be your final answer. So on to number 7, where we have, I don't know, well, circuit with 3 resistors. We're told a 12-volt battery is connected across the terminals, and then R is 62. So this is 62 ohms, and I've got a battery connected like this. All right, so there's my, and this is 12 volts. So I'm just going to see, I'm going to have I1. Why is that thicker? Shouldn't be. And then I'll say that that's I2, and I'm going to call that I3. So I'm going to have one junction equation that's I1 equals I2 plus I3. And I'm going to have 3 loops. I'll have 12 minus 24 I1 minus 75 I3 equals 0. 12 minus 24 I1 minus 62 I2 equals 0. And of course, 75 I3 minus 62 I2 equals 0. Right? I mean, you guys are old hands at that.
Yeah.
Yeah. And now all I'm doing is I'm going to put that in one of the solvers. Right? So I think I'll retreat to my keyboard to do that. So let's see. We'll use one. So A equals B plus C. 12 minus 24. A minus 75C equals 0, and 12 minus 24. A minus 62. 62B. Yay.
You get 60.10.
I read in my problem where it said the resistor marked R is 62. You see, what do they tell you yours is? There you go. Good job figuring.
Those are your answers, A, B, and C.
Yep. As I said, you guys are old hat at doing this, right?
Yes. This is old.
This is cake. So there are my currents. I1, I2, I3. And that's what they asked me for, right? I1 would be in the 24 ohm resistor, I3 in the 75, I2 in R, and then I am confident you can do part D. All right, so 12 was the next most requested, although not incredibly strongly. You got a resistor that carries this current and dissipates this much power. What's the resistance? Oh, this is like the ones you guys were doing yesterday. Cool. So we'll go green. Number 12. Power is the rate energy is used by the resistor. The more current, the faster energy is supplied. The more resistance the more energy used. Using that famous I squared R from yesterday. And then algebra again. Darn that math. And you substitute in. Alright? If you're given the power, you're given the current, you're asked to find R. Substitute away. Alright, so 13 it is. You got a resistor connected to a battery. How much energy is dissipated in the resistor in 2 minutes? Oh, they're being tricky with their time units there, minutes. Trying to throw me off. And then tricky again with kilojoules rather than joules. They're being so mean. So 13, define power. Power, rate of E and yep, that would be about it. So I know power is energy per time, right? In a resistor, I also know that it's V squared over R, right? And I want to know how much energy in 2 minutes. Oh, delta E, 2 minutes. Should I put my time in minutes or seconds? Seconds. So that's 120 seconds. They give me V, 15 volts. And they give me R, 54 ohms. Done.